System you're probably aware of contains the skin, but it also has things derived from the skin such as nails, hair, sweat glands, and sebaceous glands. Skin has two distinct regions, an epidermis and a dermis. The epidermis consists of epithelial tissue. It is avascular. Most of the cells at the top part of this epidermis are dead. The dermis underlies that. It's mostly fibrous connective tissue, and it is vascularized, and it's actually those blood vessels that are supplying nutrients and taking away waste for the cells at the lower layer of the epidermis can survive. Below that is what is known as the hypodermis, or superficial fascia. It's a subcutaneous layer below the skin. It's not part of the skin, and it's really not part of anything else. It's mostly adipose tissue that absorbs shock and insulates, but it also anchors the skin to the underlying structure, and in most cases those would be muscles. It is also the location you are trying to hit when you give someone a hypodermic injection. So let's start with the epidermis. Epidermis mostly keratinized, stratified squamous epithelium. There are four cell types found in the epidermis, the most abundant of which are keratinocytes. These keratinocytes produce a fibrous protein called keratin, which has most of the protective properties that we get from skin. Again, it's the major cell of the epidermis. The cells are tightly connected by those connections we call desmosomes, and we lose millions of them every day. In addition to those, we have melanocytes, which are kind of spider-like shaped, located in the deepest part of the epidermis. They produce the pigment melanin. It's packaged into melanosomes, and those melanosomes are then transferred to the keratinocytes, and those keratinocytes use it to protect their cells, their nuclei, from ultraviolet radiation damage. So melanocytes produce melanin, which gives us a tan, but it's produced in melanocytes but transferred to keratinocytes. There are some dendritic cells, also called Langerhans cells, which are kind of star-shaped macrophages that are patrolling the deep part of the epidermis. They are very important activators of the immune system. And then there are these sensory receptors that sense touch, called tactile cells, or traditionally referred to as Merkel cells. If you're a fan of Jimmy Buffett, it was these cells that gave rise to his skin cancer. The epidermis is made up of layers, 4 to 5 distinct layers, depending on whether you're talking about thick skin or thin skin. But thin skin, most of our skin only has the 4 layers. There are a couple of places that do have thick skin, such as our hands and our feet. But if we look at the 5 possible layers, we start at the bottom and work our way up. We have stratum basale, stratum spinosum, stratum granulosum, stratum lucidum, but that's the one that's only in thick skin, and stratum corneum. The stratum basale, or basal layer, is the deepest of the epidermal layers. It's the base layer. This layer is firmly attached to the dermis. This is a single row of stem cells that are actively dividing. And as they divide, they produce 2 daughter cells. One of those daughter cells becomes a keratinocyte and makes its way to the surface of the skin, while the other daughter cell remains as a stem cell and the bottom layer. It's also called the stratum germinatum because there's active mitosis or germination going on in this layer. About 10 to 25% of the layer is also the melanocytes. So only layers in this stratum basale, and maybe a little above it, are able to get nutrients from the vascularization of the dermal layer. The stratum spinosum looks kind of prickly, several cell layers thick, so it's not just one layer of cells. Each of those cells contains a web-like system of intermediate pre-keratin filaments that are attached to the desmosomes. This allows them to resist tension and pulling. Keratinocytes in this layer appear spiky, so they're called prickle cells, and that's where we get the name stratum spinosum. And scattered among those keratinocytes are some melanosomes, which have been released by melanocytes, and some dendritic cells, those macrophages that are patrolling the epidermis. Above that, which with about 4 to 6 cells thick, is the stratum granulosum, or the granular layer. Cells here are flattened, but the layer is still thin. It looks thinner than the other one that was 4 to 6 cells. The cells become flattened, their nuclei and their organelles disintegrate. The cell actually begins to undergo what's called keratinization. It accumulates hyaline granules that will help form keratin fibers in the upper layers. These cells also accumulate lamellar granules, which are water-resistant glycolipid that slows water loss. This is the absolute last layer where cells can survive. Above this, you can't get any nutrients from the dermal capillaries. The stratum lucidum, or the clear layer, is only found in thick skin. It consists of a thin, translucent band of 2 or 3 rows of clear, flat, dead keratinocytes. It's superficial to the stratum granulosum. And then all cells have the stratum corneum, which is also called the horny layer. It's 20 to 30 rows of flat, anucleated, keratinized dead cells, about 3/4 of the epidermal thickness. Even though these cells are dead, they still protect the deep cells from the environment. They are very important in preventing water loss, and they protect against abrasion and penetration. So these act as a physical barrier against many things. They act as a chemical barrier against many things, and they act as a biological barrier, keeping microbes out. The cells change going through a process called apoptosis that we've touched on before. It's a controlled cell death. The dead cells then slough off as dandruff and dander. And in fact, humans lose about 50 million cells every minute, skin cells every minute. And I will stop. No, I'm going to talk about the dermis. Sorry. So the dermis is a strong, flexible connective tissue. Its cells include fibroblasts, macrophages, and some mast cells, and white blood cells. The fibers in the matrix bind the body together. They make up the hide. So if you have a piece of leather, you actually have a piece of preserved dermis from an organism. It contains nerves, blood vessels, and lymphatic vessels. The epidermal hair follicles begin here. Oil glands are here. They drop their contents on the surface, but the gland itself is here, as well as the sweat glands. Like the epidermis, there are multiple layers to the dermis, but in the dermis there are only 2, a papillary layer and the reticular layer. That papillary layer is the areolar connective tissue of loose, interlacing collagen and elastic fibers along with blood vessels. Those loose fibers allow phagocytes to patrol for microorganisms, and they make a kind of butterfly-shaped structure to them, which is why they're called the papillary layer. And those ins and outs, ups and downs, contain the capillary loops, the nerve-free endings, and the touch receptors, called tactile corpuscles, or formerly Meissner's corpuscles. And those up and down regions are called the dermal papillae. And that up and down area actually makes its way all the way to the surface, or traces of it make it all the way to the surface, giving us our fingerprints. In thick skin, the dermal papillae lie on top of the dermal ridges, and that gives us the epidermal ridges, and those are more correctly referred to as friction ridges. They're there to help gripping ability, not just so that we leave fingerprints behind. They contribute to our sense of touch. And there are sweat pores in the ridges that tend to leave a unique fingerprint pattern. And here is an electron microscope of those dermal ridges. The reticular layer below that makes up about 80% of the dermal thickness. It's got coarse, dense, fibrous connective tissue. many elastic fibers providing stretch recoil properties. Collagen fibers are going to provide strength and resiliency. They bind water, keeping the skin hydrated. There's also a region called the cutaneous plexus, which is a network of blood vessels between the reticular layer and the hypodermis. And the extracellular matrix also contains pockets of adipose or fat cells. In the reticular layer, or the reticular layer itself, is the reason we have cleavage lines or tension lines. They are caused by many collagen fibers running parallel to the skin's surface. Externally, we do not see these, but we know about them, and surgeons in particular use these cleavage lines to help ensure that their cuts heal more readily. And they are mapped out here for you. There are flexure lines, which are the result of reticular layers that are dermal folds near joints. The dermis is tightly secured to the deeper structures, but the skin's inability to slide easily for joint movement causes deep creases. We can see these on our hands, our wrists, our fingers, our soles of our feet, and our toes. And one of the homeostatic imbalances we have to be aware of is the extreme stretching of the skin can cause tears in the dermis, and that, when it heals, leaves a silvery white scar tissue called striae. We typically refer to those as stretch marks. That can be from an acute short-term trauma, an acute short-term trauma can cause a blister, and that happens when the epidermal and the dermal layers separate from one another and fluid gets into that space. There's our stretch marks. Okay, now I'm going to stop.